Hi all, we can use our calculator in simulation model, which is more effective and useful. Here, we will discuss about the use of FX991 model in an emulator form. Where can we get this? www.edu.casio.com, where you can get a 90 days free trial for all models of the calculators offered by Casio, or pay and use for a long time. Alright, let's dig in to know how to use this emulator for three simple applications in engineering field. 1. The simultaneous equation, 2. The complex mode, and 3. For matrix applications. So, first, let us understand the basic requirements that should be in default in order to make use of a Casio calculator. First thing that we will have to check is what mode is the calculator is in. Here it should be in the degree mode. So you can see that D at the top of the calculator. So that should be in D, which stands for degree mode. Now entering into the first part, the simulation uh, for simultaneous equation reduction, for which go to mode. In mode, you can see the different applications that can be utilized. In this, we are going for equation solving using simultaneous equation method. So select number 5. Now it will ask what type of equation are we going for. So here we are going for simultaneous equation reduction. So what type of equation going to be, whether it is a 2 variable or 3 variable. So I select a 2 variable equation. So number 1. In what format is the data going to be loaded in? We should have the equation as ax plus by is equal to c. So constant on the other side. This is the basic format we should be using. So let us give the values as 1x plus 2y is equal to 5. Similarly, 2x plus 2y is equal to 3. So we have entered the values as accordingly. So ax plus by is equal to c for equation 1 and ax plus by plus c for equation 2. Now giving equal to will give me the solution for x is equal to minus 2 and y is equal to 3 by 5. So when we have it in rational form, then make use of S2D. This one will give us the value of 3.5. So x is equal to 2 minus 2 and y is equal to 3.5. So this is the equation. So we had the equation as x plus 2y is equal to 5. So x is equal to minus 2 plus 2 into 3.57 minus 2 plus 7 is equal to 5, and hence we get the solution for a simultaneous equation where we have two unknown parameters. The similar way, if we want to go for three unknown parameters, mode 5, and then we select 2. The same way we will be giving the values ax plus by plus cz is equal to d. So let us see, like 1 2 1 4 2 4. We can even give 0. So in the place of 0, if we don't have the parameter z in the second equation, we should provide 0 and go for the next value, and then is equal to 2. X is equal to 1, y is equal to 1, c is equal to 1, and is equal to 3. So all the data have been entered for this three unknown variables. On providing equal to will give me x, y, z. So x is equal to -1, y is equal to +1, z is equal to 3. So we can go to the last equation. X plus y plus z is equal to x plus y plus z is equal to 3. So we can see -1 plus 1 plus 3 is equal to 3, and therefore the simultaneous equation stands true. And this is the way how we will be reducing the simultaneous equation using FX991 ES models. Alright, so this makes our simultaneous equation method to be pretty easy and simple rather than going for paper and pencil work. A click will give us the solution. And now let us check how we can use the same calculator for complex modes. So to go into complex mode, again go for mode, and we say that CMPLX, the corresponding number is 2, so I select 2. And we can see at the top I get a notification that now my calculator has been set to CMPLX. So in this mode I can use the calculator as a complex reducing methods. So what is complex? Complex is nothing but a plus by, a plus bi. So let us say like 4. So where does I stand? I stands above the engineering. So 4 plus I. So it is 4 plus I. So this is a complex terminology. So when we talk about complex terms, the complex terms can be represented as a plus bi, that is in the rectangular form, or in polar form. So how to convert it to polar form? So in order to convert it to polar form, we can make use of shift. Above 2, we can see the terminology CMPLX. So click 2, I get what are all the functions that I can do with this calculator for complex mode. So now my data is in rectangular form. So I want it to be converted to the polar form. So I select number 3. So I can see that answer is nothing but 4 plus I, that is to be converted to magnitude and angle, that is to the polar form. Providing equal to gives me the actual value of polar. So it is 4.123 angle of 14 degree. The same if I want to make it in reverse. So shift 2. Now my answer is in polar form. So I want to convert it to rectangular form. So I select 4. So it goes to rectangular form. The other function is complex conjugate determination. So I select 2 again. So complex conjugate of 4 plus 3i is equal to 4 minus 3i. So how do you enter the terms in rectangular form? 4 plus 8i, which means that a plus bi. It is not a plus ib, it is a plus bi. Okay. The similar way, if we want it in polar form, we can say like 4.123 angle is just above a. So shift angle 14. So I'm having my rectangular form and polar form. Okay. So I get my solution. This is practically complex for anyone to do it on a paper and pencil method, because polar form added to a rectangular form is not easy. We will have to convert either the polar form to rectangular form and then perform addition. So when we talk about this complex method, the arithmetic tasks that we can do, like addition, subtraction, multiplication, and division. So these are the four basic things that we can do. While we do these four applications, preferably we do addition and subtraction in rectangular form. Similarly, we can do the multiplication and division in polar form, which is much convenient. All right, so now we can move on to the step number 3, that is matrix. So we can see MATRIX matrix, which is referring to the number 6. So I select number 6, and now I need to give which matrix. I can go for 3 matrix over a calculator, in a calculator. So I select matrix A1. What is the dimension of the matrix I'm going to use? Let me say it is 2 cross 2. So I have selected 2, which means that it is different. So again, we can go like mode 6 1. So I selected 2, which means that I'm going for 3 cross 2. I want 2 cross 2, which means that 5. All right. So now I give 1 2 5 9. All right. So now I have my 2 cross 2 matrix. So kindly watch for the next video where we will see the basic applications of the same FX991 calculator for matrix applications. Thank you. All the best.